Hello class. Yeah, we are toward the end of the semester. Welcome to 13th week of the semester. So this week we are working on section section 12.7 and 11.1. Yeah, we are going a little bit backward. First we will work on 12.7, then we will go back to 11.1. So today I will discuss little bit about section 12.7 and I will introduce that one. So what is on section 12.7? Section 12.7 is about L'Hopital rule. Yeah, this is about L'Hopital rule. So here I'll introduce you what does that like a L'Hopital rule means and what we will do, where we use that L'Hopital rule. Yeah, L'Hopital rule is to evaluate limit of certain expression, to evaluate given limit. So what type of, in what situation we will use that L'Hopital rule? Let me tell you here. For example, suppose you have given expression limit x approaching to 0 and you have x to the third over e to the x minus 1. Suppose you have this expression and you have to evaluate limit. Yeah, in like in calculus 1, I believe like around the beginning of calculus 1, say chapter 3, you learn how to evaluate different types of limit. There you learn like to simplify expression and to cancel common factor and top and bottom and evaluate that type of limit. But sometimes that might not work. So that's why we are introducing that L'Hopital rule here. So yeah, in this case, what is the very first step to evaluate limit? First of all, you will plug in the given limit in given expression. Let us plug in what happens. When you plug in x equals to 0 in given expression, what we get here? Look, 0 over, on the top it is 0, right? 0 to 3 is 0 over e to the x. E to the x means e to the power 0 minus 1. E to the power 0 is 1, right? 1 minus 1, which is 0 over 0. Okay, so we got that 0 over 0. This is a type of indeterminate form. You know, like a 0 over 0 is a type of indeterminate form. You know what is indeterminate? For example, you have 0 candies and you are distributing to 0 people. That doesn't make any sense, right? But for example, if you have 1 candy and you have to distribute with 0 people, that doesn't make any sense, right? That doesn't have any meaning. So that is what we call, this is undefined value, that is meaningless, that is undefined. So but 0 over 0, you divide the number 0 by 0. If there is other number on the top, this is directly undefined one. But if you have 0 over 0, same number and same number, this is what we call indeterminate form, not determined yet. Indeterminate form. If you have that type of indeterminate form, then we can use L'Hopital rule to find limit. What does that L'Hopital rule does? That L'Hopital rule tells us if you have this type of indeterminate form, then you can find derivative of the top separately and derivative of the bottom separately. I am telling you separately. Don't use quotient rule here. Just use the derivative of top part and derivative of bottom part separately, then plug in the limit. So yeah, that is the step of L'Hopital rule. So by L'Hopital rule, so what we do here, we find the derivative of top, we write the limit same, s tends to 0, derivative of top 3x square, right? Derivative of top is 3x square and derivative of bottom is e to the x. Yes, and derivative of e to the x is e to the x minus 1 is derivative of 1 is 0. So yeah, we found derivative now. Let us plug in limit. Now what we will get now? When you plug in x equals to 0 now, on the top 3 times 0 is 0. On the bottom e to the power 0 is 1 minus 0. So we got 1. So what is 0 over 1? This is existing value, right? When you divide 0 candy to 1 people, everyone will get 0. So that's why this is okay. The result is 0. Yeah, so we got that limit. So here otherwise like we don't have any other like idea of factoring or something like that, but in this case, in such case, if you get 0 over 0, that is one type of indeterminate form, at that time you can use that L'Hopital rule. Yes, for example, if you had got like another 0 on the bottom here also, again you repeat the L'Hopital rule. You do the derivative of top again and do the derivative of bottom. Similarly, the other situation you can use that L'Hopital rule is if you get directly infinity over infinity. Instead of 0 over 0, if you get infinity over infinity, there also you can use L'Hopital rule. Okay, or sometimes we might have some other undefined indeterminate form that they can lead to either of 0 over 0 or infinity over infinity. If you can convert those indeterminate form in either of infinity over infinity or 0 over 0, that time also you can use L'Hopital rule. Here I am going to give you some other example relevant to those things. Let me do that. For example, suppose you have to evaluate, here is another example, limit x tends to 0, another one, e to the x minus 1 over x square. Look over this example. In this example, if you plug in limit directly, what happens there? When you plug in x equals to 0, e to the 0 is 1 minus x 0, this is 0 minus 1. 1 minus 1 is 0 on the top and 0 square is 0 on the bottom. Here you can directly use L'Hopital rule. L'Hopital rule. By L'Hopital rule, find the derivative of top, limit x tends to 0, e to the x. E to the x derivative of e to the x is e to the x minus derivative of x is 1 minus derivative of 1 is 0 and the bottom part is 2x. So now when you got the derivative, then you check what you got there. E to the 0, 1 minus 1. 1 minus 1 is 0 on the top and 2 times 0 is 0. So we got 0 over 0. Look. So we again got 0 over 0. This is indeterminate form. There we can use L'Hopital rule. Okay, then again we use L'Hopital rule again. So that gives us limit x tends to 0. You write that limit, don't forget that one. E to the x, derivative of e to the x is e to the x minus derivative of 1 is 0, 0 is 0. Divide by derivative of 2x is just 2. Now plug in limit. E to the power 0 is 1 on the top and 2 on the bottom. So that's why this is limit of this function. Here we use L'Hopital rule 2 times, right? Because we got 0 over 0. So this is another case. Let me work with like so we can see somewhere infinity over infinity. or something. Infinity over infinity or something. Okay, so look, here is another example. X times ln of x, limit x tends to 0 plus from the positive side. X is approaching to 0 from the positive side. When you plug in limit, because for negative side ln is not defined, that's why we are using that 0 plus here. Let us plug in 0 in this given expression. What happens? X equals to 0 means 0 times ln of 0 is undefined, that is infinity. Oh, we got 0 times infinity. Okay, so this is not 0 over 0, or we have to have either of these condition for L'Hopital rule. But in this case, we got 0 times infinity. This is not either of these form, right? So what I am telling you, sometimes these indeterminate form can lead to either of 0 over 0 or infinity over infinity if you write them in different way. For the same thing, if you write in different way, you can get either 0 over 0 or infinity over infinity. Let us see here. I know on the top ln of x, you cannot change that ln of x position. But what I can do, let me use that big denominator whole over 1 over x. Look, for this x, what happens? You know that complex fraction, right? If you have a over b whole over c over d, then what happens? That will lead to a over b times c over d, right? The d over c. The bottom will flip, right? D over c. A over b times d over c. The bottom flips. Here also, if you write in this way, what happens? The bottom will flip, right? What is bottom? 1 over x. If that bottom flips, then that x will go on the top, right? So you will get the same thing. For the same thing, I am writing in different way. I am trying to make the denominator, numerator and denominator there. Okay, so writing in this way, like this is what we call complex fraction. Yeah, but limit is same, x tends to 0 plus. Yeah, let us plug in limit. What you will get there? Ln of 0 plus is, that is infinity, and 1 over 0 is what? You divide some number by 0 is, that is undefined. Yes, now we lead to infinity over infinity. There, if you have this situation, now you can use L'Hopital rule. Now you can use L'Hopital rule, right? So there you can use L'Hopital rule. Now what happens? The derivative of top part, the derivative of ln of x is 1 over x whole over. Now derivative of 1 over x. What is 1 over x? This is x to the power negative 1, right? What is derivative of x to the power negative 1? Negative 1 times x to the power negative 1 minus 1. So yeah, that is what? Negative 1 x to the negative 2, which is written as negative 1 times negative 1 over x square, right? That negative power when go on the bottom, that will be x square. So in this case, you will get negative 1 over x square, the bottom part, right? So limit x tends to 0 plus is equals to this one. Now, if you plug in limit 1 over 0 infinity, 1 over 0 infinity, okay, in this complex fraction we got 0 infinity over infinity. But let us simplify this one. Let us flip this one and write in simple form and check the limit, what happens, okay? So 1 over x, let us flip the bottom part, 1 over x times negative x square over 1. This is how we write by flipping that bottom, right? Let us see what happens here. So you got, look, negative x square on the top and x on the bottom. That is what we got. Limit x tends to 0 plus. Now look what we got. X square over x. So what is x square over x? Well, one x we can cancel, right? So we got limit x tends to 0 plus negative x. So that means when you x over x 1 cancel, so we got negative x. So when you plug in x equal to 0, so we got 0. Yeah, so here we got value 0, right? The limiting value is 0. Yeah, I believe that will make sense for you. Yeah, this is another type. We got like infinity over infinity. Sometimes that 0 times infinity or infinity times 0 can lead to either 0 over 0 or infinity over infinity. In that form, be aware of that one. So this is another type you can see. And the third type, let me take one example from exercise. Yeah, this is number 43 from your exercise. Here we have limit x tends to 0, e to the x over x square minus 1 over x square minus 1 over x. Look. So we have this condition. Now let us plug in limit. That is our first step. E to the 0 is 1 over 0. 1 over 0 is infinity. Here second one also infinity. Third one also negative infinity. Oh my goodness. Infinity minus infinity, infinity. This is undefined. This is indeterminate form. Let us try whether we can make either in 0 over 0 or infinity over infinity. What I'll do, I'll try to combine these fractions first. Okay. So both of them has same denominator, and the third one has x over x. I'll write that like that, x over x. So now we have all same denominator. Let me combine this fraction first. X tends to 0. So we got e to the x minus 1 minus x over x square. Okay. So so this is, now let us plug in what happens now. E to the 0 1 minus 1 minus 0. 1 minus 1 0 minus 0 is 0 on the top and 0 on the bottom. Oh, we got 0 over 0. Yeah, there we can use L'Hopital rule now. Look, L'Hopital rule. So that tells us now find the derivative of top and derivative of bottom separately. The derivative of top will be e to the x is e to the x minus derivative of 1 is 0, derivative of x is 1, derivative of bottom is 2x, x tends to 0. Okay, so when we find that derivative, now let us see what happens now. The top part is e to the 0 minus 1, e to the 0 is 1 minus 1 is 0, bottom part is also 0. One more time, again we got 0 over 0. Let us find derivative again. E to the x is e to the x minus 0 is 0 minus derivative of 1 is 0 and derivative of 2x is 2. Let us plug in limit now. What happens? E to the 0 is 1 minus 0 is 1 over 2. Okay, again we got 1 over 2. So this is our answer. So you will see that type of problem in this section 12.7. So this should be easier for you. Just if you get 0 over 0, infinity over infinity, or some other indeterminate form, infinity minus infinity, or 0 times infinity, or infinity times 0, they might approach to infinity over infinity or 0 over 0 at that time. First of all, you will make that condition either 0 over 0 or infinity over infinity, then you will apply L'Hopital rule. Hope this will help you to understand this section. Keep working.